little bit of help on the open-ended log equation hand-in assignment, particularly questions 8 and 9, and also talking about restrictions when you're solving equations. All right, when you are solving log equations, you have to be aware of the definition of the log function. So what is the definition of a log function? Y equals log base b of x. And what are the restrictions of the variables? This is very, very important. Otherwise, you're not going to do well on this worksheet. What's b? Or what's x? X has to be greater than 0. That doesn't mean x in the equation that you are solving. That means whatever is here. Okay, and b has to be greater than 0. The base has to be greater than 0 and not equal to 1. All right, so how does that apply to this? Well, when I am doing a question like, say, number 4, well, let's, which one has a reject? Okay, almost all of them. Okay, so if we just look at number 4, it's not the x that can't be negative, it's the 4 minus x. Do you see the difference? It's all of this that mustn't be negative. So when you substitute in, it's all of this. Okay? So that's idea 1. The second thing that I'd like to talk about is how to do a question, like your strategy for doing questions 8 and 9. Because the students are going to have, some students have great difficulty. I don't want to do it for you, otherwise I take away all your fun. But if we look at, let's say, number 9, and just some clues on how to do number 9. First of all, focus on the question. It says, write log base 2 of 30 in terms of x and y. It's kind of different. That means you're to take this and you're to rework it step by step, show all your work, and your final answer, it's not really an answer, but your final form of this is to, contain only x's and y's. So they might be like just for example, it could be 3x plus 2y. I mean, that's not the answer, but do you understand? That's rewriting this in terms of x's and y's. That's what you're trying to get to. All right, so knowing that, how are you going to do it? Well, you have to have, they give you some information. And the extra information they gave you was that log base 8 of 3 was x, and log base 16 of 10 is y. All right, so what are the rules of this game? This is a game. You go from here, you get down here, it has only x's and y's. This is what the log math people love, to play games, all right? So what are you allowed to do? What are the rules? You're only allowed to use the log laws. What laws are those? They're these ones, like the log of a product. The log of a product can be rewritten like this. So if you feel like it, you can use this law. I feel like it when I see log of 30 and I see a 3 and a 10, and I know that 3 times 10 is 30. Okay, what other laws would be very useful for this question? Well, the change of base law. Why change of base? Well, I see a 2, I see an 8, I see a 16. They're all different bases. So obviously, I'm going to be using the change of base law. What's the change of base law? It's a law that says if you're in base B and you feel like going in a different base, here it is in base 10, right? Here it is in base 3. Doesn't matter. Whatever base you want to go to. All right? It's called the change of base law. So for this question, here's my approach again. I'm going to just summarize this. You're going to take this expression, you're going to step by step rewrite it using the log laws and only the log laws. Don't make up your own. And I'm allowed to, at any given time, substitute these in. Now, this is not going to help me like this, but I could take this one and rewrite it. I could take this one and rewrite it. But you can see that this is written in terms of x. That's nice, because I'm supposed to have x's down here. Okay, so that's the game. Start with this, rewrite it. When you can't do anything else, go over here, rewrite these, see if you can substitute in, and play that game. That's all I'm going to say about that one. When you look at question 8 on this worksheet, question number 8, the first thing that sticks out to you is what? The first thing that sticks out to you is that the bases are not the same. You can't solve an equation where the bases are all different. Now, this doesn't mean we're going to all change a base and go to the same base. I'm not doing this question because there actually are different ways to do this. People will approach it differently. But you can do different things. When you see 4 and 8, they both can be put into base, what? 2. All right? And that's a useful thing to do in this question, to rewrite these in base 2. Not this. This isn't useful to put that into base 2. But this is a what? This is a product. So those are my clues for that question. I'm telling you, reminding you that this is a product, and these are both, these numbers can be written into, rewritten in base 2. And those two hints will help you do number 8.
What number 10?
Number 10. Number 10 is easier than the other two. Number 10 is just a straight ahead. There's nothing weird going on there. The only thing strange in number 10, and it's not that strange, is that you have 2 different bases. So in this particular question, I would just automatically change both of these to base 10. Or base 2. I think I'd go to base 2 because I see the 4. See, the more you play with these, the more you'll see that that's a helpful thing. Like if I go to base 2, this particular expression right here becomes log base 2 of x. That's nice for this, right? And then it's over log base 2 of 4. And log base 2 of 4 can be replaced with? This is 2. So that's a really nice little substitution to make. So experience is what helps you do this. You see 4, it's a base, can be put into base 2, right? Yeah. So that's what I would do. I wouldn't go to base 10, I'd go to base 2. Make sure you show all your work and have fun. I don't want to do these, but have fun.